quite often we need to show inequalities or represent them on a number line. If we have a hollow black dot, that just means an empty circle, and we use these to represent less than and greater than. A solid black dot or a coloured in circle represents is less than or equal to, or is greater than and equal to. So we can see, looking at this example, because we've got a coloured in dot, this is showing us that x is greater than or equal to -1. So that means x could be -1, or it could be anything greater than -1. And this arrow shows us that it's not coming to an end, that it could go on forever. So it could be 4 million or 4 billion. Okay, the most important bit though is this coloured in black dot means it could be -1, because x is bigger than or equal to -1. In this example, the circle isn't coloured in, so this is showing us that x is less than 2. So it can't actually be 2. It could be 1.9999999 going on and on and on and on, but it can't actually be 2. It could be really, really close to it, but not 2. Again, this end, the arrow, shows that it's not got an end to it. So it could be anything less than 2. In this example, we have got two ends. So this is showing us that x could be -1 because it's coloured in. It can't be 3. So it could be -1, anything greater than -1, but only going up to 3. And it's written like this. So it's saying -1 is less than or equal to x, and x is less than 3. So you can see the -1 is being shown by a coloured in black dot because it is less than or equal to, and the 3 is being shown by an empty, a hollow circle because it is just x is less than 3. So where we've got that extra line means that the circle is coloured in because it can include that number. Sometimes we're given an inequality and asked to list all possible solutions if, and this is the important bit, n is an integer. That just means if it's a whole number. So let's look at this example together. This is telling us that -3 is less than n and n is less than 4. So we know if we picture this on a number line, we know that n is between -3 and 4. So we need to write out all the numbers between -3 and 4. Now we need to come back to the inequality. This is saying that -3 is less than n. It's not and or equal to. So it can't actually be -3 because -3 is less than whatever n is. Also, n is less than 4. There's no extra little line. So n can't actually be 4. It's got to be less than 4, which means we cross out this end one. So the possible solutions for n are -2, -1, 0, 1, 2 or 3. Let's have a look at the second one, but this time I'm going to add in an extra line, and on this one I'm going to add in extra lines on both of them so you can see what these would look like. So for this second example, again we know n is between 2 and 8, so I'm going to write out all the numbers between 2 and 8. Now I look back at the inequality. This time 2 is less than or equal to n, so 2 could be equal to n, so I'm going to keep it. However, n has to be less than 8. It can't be 8 itself, so I get rid of 8. So possible solutions are 2, 3, 4, 5, 6 or 7. So hopefully you're starting to see now, if I've got that extra line, it means I can keep that number. If there's not the extra line, then I have to get rid of that number. So this last example then. This time I know n is between -4 and 0. So I'm going to write out all the numbers. -4, -3, -2, -1 and 0. -4 can be equal to n, so I keep it, and n can be equal to 0. So I'm going to keep all of those numbers, and possible solutions are -4, -3, -2, -1 or 0.